In our previous video, we set up our equation. Trig function of acute angle is equal to the ratio of the two sides. We decided to use tangent because from the 60-degree angle's perspective, we knew the adjacent side to it and we wanted to know the opposite. The hypotenuse of that right triangle is not part of this problem. So opposite over adjacent is our tangent ratio. So we have one unknown in this equation, and that is h. And so we know from algebra that when we want to isolate or solve for a variable, we need to get rid of anything that's on the same side of the equation with it. And so in this case, it's the 3. So we have to use inverse operations to get the variable by itself, and this is division between the variable and the 3. So to undo division, we're going to use multiplication. So we're simply going to multiply both sides of the equation by 3. So this 3 in the numerator cancels out that 3 in the denominator, since 3 divided by 3 is 1. And so h is simply whatever 3 times the tangent of 60 is. So that's what we're going to put into our calculator. So again, just make sure you're in degree mode anytime you are doing trig of any kind in your calculator. Remember, pressing the clear button does not change the mode, but second plus 712 will. So I'm going to type in 3 tangent. Notice it brings up the parentheses for the 60. We talked about how you can or don't have to put the end of the parentheses there because you're not typing anything afterwards. So it does not tell us what we're rounding to. We will just round to the nearest tenth. That is 5.2, and the units were feet. Now when we did special right triangles, we said this was 3 square roots of 3 because we multiply the short leg times the square root of 3. But if we put in 3 square roots of 3, you will see that that's the same exact decimal as the one we got with trig. Now the other question is to find how long the wire needs to be, which is this length right here. So again, in respect to the 60-degree angle, I'm given the adjacent leg. But this time, the opposite is not involved in the problem. The c is the hypotenuse. So which trig function uses hypotenuse and adjacent? So if you go back up to your little reminder up here, adjacent and hypotenuse are used in cosine. So we want to write a cosine equation to solve for c. So we would write our trig function, which is cosine, of what acute angle, we're using the 60-degree angle, is equal to what ratio of two sides? Well, cosine is always adjacent over hypotenuse. So from the 60-degree angle's perspective, the adjacent is 3. That goes in the numerator. And the hypotenuse is my unknown c. So again, we have an unknown that we need to solve for. This time it's in the denominator. So when we multiply both sides, we're not multiplying by 3, because if I multiply this side by 3, I now have 9 over c. I have not helped myself at all. So instead, we're multiplying by what's in the denominator, just like we did here, on both sides. So now I'll no longer have a variable in the denominator. I have c times the cosine of 60 equals 3. But I still have not gotten my c by itself. I need to get rid of this cosine of 60. But to do so, I need to undo multiplication, so we know we use division. So I'm going to divide by the cosine of 60, and what I do to one side, of course, I have to do to the other to keep it balanced. So when we divide a number by itself, it's 1, so those cosine of 60s cancel, leaving with c by itself. So c is equal to 3 divided by the cosine of 60. So that's what we're going to be putting in our calculator. 3 divided by the cosine of 60. And you'll see we get the same thing we got when we did our special right triangles. We knew from special right triangles the hypotenuse was double the length of the short leg, which is 6. And that's exactly what we get here. 6 feet, that is. Okay, so one thing I want you to notice is that when your variable's in the numerator, you end up multiplying the number times the trig function. But when your variable's in the denominator starts with d, that'll remind you you're always going to end up dividing your number by the trig function. So you'll start noticing patterns and not have to show all these steps every single time. Variable in the numerator, I multiply the number times the trig function. Variable in the denominator, I divide the number by the trig function. All right, so let's look at continuing the lesson here. So question 6 in our notes. So John is flying a kite and has let out 100 feet of string. He is holding the string 5 feet above the ground at an angle of 40 degrees with the horizontal. Can you solve the puzzle to find the approximate altitude of the kite? So remember, altitude is this segment that represents the height of the kite. And so we've got to decide which trig function we're going to be using. So remember, you always look from an acute angle's perspective, and in this case we're given the 40 degrees as our acute angle. So in respect to the 40 degree angle, the side that we want to know would be called its what? Is that the opposite, adjacent, or hypotenuse? Well, that is the opposite side. The side that we're given to be 100 feet is the hypotenuse. It's across from the right angle. Remember, height always is perpendicular to the base, which in this case is the ground. So which one of our trig functions uses opposite and hypotenuse? So again, we kind of flip the page on our notes here. So you might want to rewrite that acronym that is really helpful to memorize, which is SOHCAHTOA. That helps you remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So our height is the opposite side to our given angle. The 100 feet is the hypotenuse, so opposite and hypotenuse are using sine. So we're going to write a sine function here of our acute angle, which is the 40 degree angle. So we're using this answer, sine of 40. We're going to set that equal to the ratio of the two sides using the opposite over hypotenuse ratio. So opposite is my h, hypotenuse is my 100. So we just got finished talking about which operation to use, multiplication or division, depending on where the variable is. Since my variable is in the numerator, I'm simply going to multiply the 100 times my trig function of sine of 40. If h would have been in the denominator, I would have 100 divided by sine of 40. But it's in the numerator, so we are multiplying. So we'll just simply put into our calculator 100 sine of 40. And we see that when we round to the nearest tenth, we get this answer, the 64.3 feet. Don't forget units anytime your units are given. All right, on number 7, we've been on the last couple of examples solving for missing side lengths, but we can also solve for an unknown angle of a right triangle. So we can solve for that acute angle measure. So we're going to look at that here. So the first step is to write your trig equation exactly in the same format we've been doing, which is trig function of the acute angle equals the ratio of the two sides. But you're going to, instead of having a number to put in for the acute angle, that is going to be your variable. So in this case, we're looking at this right triangle we're given two sides of, and we're trying to find what the measure of angle A is. And so they have already determined that we're going to be using sine. And the way they determined that is in respect to the angle we're wanting to know, which is angle A, the sides that we know are the opposite to angle A and the hypotenuse of the triangle. And so opposite and hypotenuse tells me I need to use sine as my trig function. So when I replace with the information that I know, I'm replacing the opposite with 12 and the hypotenuse with 13. So my variable is the A. That's what I'm trying to find out. What is the measure of angle A? So I've got to get rid of sine in order to get A by itself. Now remember, sine is not a number. This is not sine times A. So we can't just divide by sine. That would be like dividing by a square root symbol. That just does not make sense. Sine is an operation. So we need to undo that operation. And so remember, to undo operations, we use inverse operations. If we want to undo addition, we use subtraction. If we want to undo square roots, we square. So we have to have an inverse operation for sine as well. And we do. It is the inverse sine. So we're going to take the inverse sine of both sides. Inverse sine cancels out sine, leaving we with the measure of angle A. So to find the measure of angle A, I'm simply going to take the inverse sine of that opposite over hypotenuse ratio. So we find that the measure of angle A, if we're rounding to the nearest thousandth, is 67.380. The way that is entered in the calculator, inverse sine is in blue above sine, so you would need to hit the second key first and then sine, and it'll bring it up there for you. And then you can type in your 12/13 ratio. Again, you can close it or not close it. It does not matter. But there's the same answer they were able to get. Remember, your calculator will give you an error if you try to ask for the inverse sine of 13/12. That doesn't make sense for an opposite over hypotenuse ratio because the hypotenuse has to be the longest side. All right, so let's look at question 8 in our notes. We are told our school is growing and has added a portable building. The 3 steps that lead to the building rise 24 inches. So that's given right here. The school needs to put it in a ramp to make the building wheelchair accessible, and by law the ramp must have an angle of elevation no greater than 15 degrees. So this angle has to be 15 degrees or less. The maintenance crew has a board that they want to use to make the ramp, and the length of the board is 85 inches. And we want to know, is the board long enough? Can R be 85 inches? So can R be 85 inches? That is the question. All right, so let's look at setting up our equation here. So here's our angle whose perspective we're looking from. In respect to that angle, these are the sides that I know. I know the 24 inches, which is the side that is opposite the x degrees. And I know the 85 inches, which is across from the right angle. So that is my hypotenuse. So which trig function uses opposite and hypotenuse? Well, again, that is sine, right? Sine is opposite over hypotenuse. So I'm going to set up a sine equation. So the sine of the acute angle, which in this case is x, is equal to the opposite, which is 24, over the hypotenuse, which is 85. So to get rid of the sine, we have to use inverse sine. So x is simply going to be the inverse sine of 24 over 85. So that's what I'm going to put in my calculator. Let me minimize that. Second sine of 24 over 85. And remember, we want this to be 15 degrees or less. And it is not. Okay, so no, the board is not long enough because it does not create an angle that is 15 degrees or less. So we want to know what is the minimum length of board needed for the ramp. So now we're going to be leaving R as the hypotenuse. The 24 is still my opposite, but now we're going to replace this angle with what we know it can be, which is 15 degrees. So it's going to look exactly like this equation here. It's just the information that I fill in is different. So I'm going to have sine of, instead of x, I'm going to be putting in the 15 degrees. And the 24 is still my opposite, but this time my unknown is the length of the board. We're trying to figure out, well, what does it have to be? So remember we talked about where our variable is tells me whether I'm using multiplication or division. And this time my variable's in the denominator. Denominator starts with D. That's your reminder that you're going to use division. So to find that length of that board, it's always the number first. So 24 is going to be divided by the trig function sine of 15. So that's what I'm going to put in my calculator is 24 divided by the sine of 15. So it looks like my board, it doesn't tell me really what to round to, so we'll just round to the nearest whole number. My board needs to be at least 93 feet long.